Most people are not very familiar with the concept of artificial intelligence. As an illustration, when 1,500 senior business leaders in the United States in 2017 were asked about AI, only 17% said they were familiar with it. A number of them were not sure what it was or how it would affect their particular companies. They understood there was considerable potential for altering business processes, but were not clear how AI could be deployed within their own organizations. Despite its widespread lack of familiarity, AI is a technology that is transforming every walk of life. It is a wide-ranging tool that enables people to rethink how we integrate information, analyze data, and use the resulting insights to improve decision-making. Our hope through this comprehensive overview is to explain AI to an audience of policymakers, opinion leaders, and interested observers, and demonstrate how AI already is altering the world and raising important questions for society, the economy, and governance. In this video, we discuss novel applications in finance, national security, healthcare, criminal justice, transportation, and smart cities, and address issues such as data access problems, algorithmic bias, AI ethics and transparency, and legal liability for AI decisions. We contrast the regulatory approaches of the US and European Union, and close by making a number of recommendations for getting the most out of AI, while still protecting important human values. Qualities of artificial intelligence. Although there is no uniformly agreed upon definition, AI generally is thought to refer to machines that respond to stimulation consistent with traditional responses from humans, given the human capacity for contemplation, judgment, and intention. These software systems make decisions which normally require human level of expertise and help people anticipate problems or deal with issues as they come up. As such, they operate in an intentional, intelligent, and adaptive manner. Intentionality. Artificial intelligence algorithms are designed to make decisions, often using real-time data. They are unlike passive machines that are capable only of mechanical or predetermined responses. Using sensors, digital data, or remote inputs, they combine information from a variety of different sources, analyze the material instantly, and act on the insights derived from those data. With massive improvements in storage systems, processing speeds, and analytic techniques, they are capable of tremendous sophistication in analysis and decision-making. Intelligence. AI generally is undertaken in conjunction with machine learning and data analytics. Machine learning takes data and looks for underlying trends. If it spots something that is relevant for a practical problem, software designers can take that knowledge and use it to analyze specific issues. All that is required are data that are sufficiently robust that algorithms can discern useful patterns. Data can come in the form of digital information, satellite imagery, visual information, text, or unstructured data. Adaptability. AI systems have the ability to learn and adapt as they make decisions. In the transportation area, for example, semi-autonomous vehicles have tools that let drivers and vehicles know about upcoming congestion, potholes, highway construction, or other possible traffic impediments. Vehicles can take advantage of the experience of other vehicles on the road without human involvement, and the entire corpus of their achieved experience is immediately and fully transferable to other similarly configured vehicles. Their advanced algorithms, sensors, and cameras incorporate experience in current operations and use dashboards and visual displays to present information in real time so human drivers are able to make sense of ongoing traffic and vehicular conditions. And in the case of fully autonomous vehicles, advanced systems can completely control the car or truck and make all the navigational decisions. Applications in diverse sectors. AI is not a futuristic vision, but rather something that is here today and being integrated with and deployed into a variety of sectors. This includes fields such as finance, national security, healthcare, criminal justice, transportation, and smart cities. There are numerous examples where AI already is making an impact on the world and augmenting human capabilities in significant ways. Finance. Investments in financial AI in the United States tripled between 2013 and 2014 to a total of $12.2 billion. According to observers in that sector, Decisions about loans are now being made by software that can take into account a variety of finely parsed data about a borrower, rather than just a credit score and a background check. In addition, there are so-called robo-advisors that create personalized investment portfolios, obviating the need for stockbrokers and financial advisors. These advances are designed to take the emotion out of investing and undertake decisions based on analytical considerations, and make these choices in a matter of minutes. A prominent example of this is taking place in stock exchanges, where high-frequency trading by machines has replaced much of human decision-making. People submit buy and sell orders, and computers match them in the blink of an eye without human intervention. Machines can spot trading inefficiencies or market differentials on a very small scale and execute trades that make money according to investor instructions. Powered in some places by advanced computing, these tools have much greater capacities for storing information because of their emphasis not on a 0 or a 1, but on quantum bits that can store multiple values in each location. That dramatically increases storage capacity and decreases processing times. Fraud detection represents another way AI is helpful in financial systems. It sometimes is difficult to discern fraudulent activities in large organizations, but AI can identify abnormalities, outliers, or deviant cases requiring additional investigation. That helps managers find problems early in the cycle, before they reach dangerous levels. National security. AI plays a substantial role in national defense. Through its Project Maven, the American military is deploying AI to sift through the massive troves of data and video captured by surveillance and then alert human analysts of patterns or when there is abnormal or suspicious activity. According to Deputy Secretary of Defense Patrick Shanahan, the goal of emerging technologies in this area is to meet our warfighters' needs and to increase the speed and agility of technology development and procurement. The big data analytics associated with AI will profoundly affect intelligence analysis, as massive amounts of data are sifted in near real time, if not eventually in real time, thereby providing commanders and their staffs a level of intelligence analysis and productivity heretofore unseen. Command and control will similarly be affected as human commanders delegate certain routine, and in special circumstances, key decisions to AI platforms, reducing dramatically the time associated with the decision and subsequent action. In the end, warfare is a time-competitive process, where the side able to decide the fastest and move most quickly to execution will generally prevail. Indeed, artificially intelligent intelligence systems, tied to AI-assisted command and control systems, can move decision support and decision-making to a speed vastly superior to the speeds of the traditional means of waging war. So fast will be this process, especially if coupled to automatic decisions to launch artificially intelligent autonomous weapon systems capable of lethal outcomes, that a new term has been coined specifically to embrace the speed at which war will be waged: hyperwar. While the ethical and legal debate is raging over whether America will ever wage war with artificially intelligent autonomous lethal systems, the Chinese and Russians are not nearly so mired in this debate, and we should anticipate our need to defend against these systems operating at hyperwar speeds. The challenge in the West of where to position humans in the loop in a hyperwar scenario will ultimately dictate the West's capacity to be competitive in this new form of conflict. Healthcare. AI tools are helping designers improve computational sophistication in healthcare. For example, Merantix is a German company that applies deep learning to medical issues. It has an application in medical imaging that detects lymph nodes in the human body in computer tomography images. According to its developers, the key is labeling the nodes and identifying small lesions or growths that could be problematic. Humans can do this, but radiologists charge $100 per hour and may be able to carefully read only 4 images an hour. If there were 10,000 images, the cost of this process would be $250,000, which is prohibitively expensive if done by humans. What deep learning can do in this situation is train computers on datasets to learn what a normal-looking versus an irregular-appearing lymph node is. After doing that through imaging exercises and honing the accuracy of the labeling, radiological imaging specialists can apply this knowledge to actual patients and determine the extent to which someone is at risk of cancerous lymph nodes. Since only a few are likely to test positive, it is a matter of identifying the unhealthy versus healthy node. AI has been applied to congestive heart failure as well, an illness that afflicts 10% of senior citizens and costs $35 billion each year in the United States. AI tools are helpful because they predict in advance potential challenges ahead and allocate resources to patient education, sensing, and proactive interventions that keep patients out of the hospital. So that's it for today. If you find this video helpful, please give it a big thumbs up and share it with others. Also, if you haven't already, please consider subscribing to our channel. Don't forget to turn on the notification bell so you don't miss any of our new uploads. In the end, thanks for watching and see you next time.